Hello, everyone. I'm Steaming Cup of Reason, and welcome to episode 11 of Logic and Reason. Unfortunately, Logical Troglodyte could not be with us today, but I'm sure that he will pop in later if he can. Today, we are proud to bring you our inaugural stream on the EIE network. I messed that up. Go figure. We are making our first broadcast of Logic and Reason on the new EIE network, or I network as we call it, where you can find entertainment, information, and education all in one place. So go ahead and hit that subscribe button and remember to tap the bell to get notifications for all your favorite content here on the I network. We have a great show lined up for you today as we continue our series on the scientific method, as we discuss the many and varied methods of doing research and how research is often misunderstood or misapplied by those in the conspiracy theorist community. So let's begin by introducing our guests for the show today. Firstly, returning once again to continue the discussion that we had with our friend AB Science. Say hello, AB. How are things going with you?
Hello. Yes, I'm doing well. Thank you very much. I've had a busy kind of week of video releases and streaming, and excited to be here and to pick this topic up again. Last time we talked about different ways of doing experiments, and we'll be extending that here with just different different ways of doing research.
Yeah, awesome. I've really been enjoying the way you've been taking apart Mr. Apophis. That's been great. Can't wait for the next one.
Yeah, he's a fun one. There's lots of weird coming in there, but yeah.
Oh man, can't wait for that. And next, we are extremely pleased to have a very special guest with us today, a man who is going to give us a unique viewpoint on how we do research. Not only is he a proud serviceman in the U.S. Army at the rank of Chief Warrant Officer, but also a highly experienced criminal investigator, BM Furball. Say hello, BM. How are things with you?
I'm doing good. Thanks, guys. It's good to be back in the States after a long trip from Korea and then a packing of a house and a long drive and now a slow unpacking of a house. But we're settling in. I'm back to work. Kids are at school. Things are starting to get normal again. So it's great to be back online and be back with you guys.
Well, it's great to have you on the show today. Really looking forward to this one. It's going to be fun. And of course, we can't forget the lovely lady who keeps things together in the chat, our chief mod, Amy Hogan. Say hello, Amy. Amy, how are you?
I'm great, thank you. How are you? Good morning, everyone. Good. Good morning, everyone. I hope you enjoy the show, and thank you for coming.
Awesome. Fantastic. And just a quick reminder to all the mods in the chat, we kindly ask you not to time out, block, or ban anyone from the chat unless they are being particularly racist, homophobic, or just plain nasty or off topic. Anything else is fair game. And if it's warranted, we may even respond to it in our discussion. And finally, let's not forget the man who keeps it all running. Is he man or is he machine? Whatever it is, he keeps it all going. Taddy Bogle. Say hello, Taddy.
I have to say that not only am I half man, half machine, I'm 100% out of this one, man. This is a pay grade or two above where I come in normally. And what can I say?
Really?
This is going to be a fantastic conversation. I may have some questions myself.
Yeah, I agree with you, Taddy. I agree with you. And with that, let's get things going. I think I'd like to start by getting a general sense of how each of our guests approach researchers in their respective fields. So let's begin with our returning guest, AB Science. AB?
Yes. How do we approach the research? Well, I'm in the physics game, so it is pretty straightforward. We develop our framework, and we have the established theory, and then we take little things about the theory where we go, all right, we know that we have observed this, so what is the logical extension of that? And we make a new prediction. and then we test that prediction. We in physics we tend to just use very very straightforward lab-based experiments, the classic experiment that you would be familiar with. However, on the side, I do work with another project where we look into educational research, and there we have a completely different approach. We don't have the luxury of a lab-based experiment or anything like that. What we have to do is we have to employ observational techniques where we just have large data sets, and we're really on the extreme end. On the other extreme, we do not have the luxury of manipulating your independent variable physically by, twisting a button or pushing a slider or anything like that. And we have to kind of take the data and make inferences.
Yeah, more qualitative rather than quantitative research.
It is quantitative, but it is observation based rather than experimental.
And how about you, BM? How do you approach research in the world of criminal investigation?
Well, there's a couple different aspects to it. There's the cop on the ground side to it, the investigator on the ground side to it, and then there's the actual laboratory side to it. And from my personal perspective on the ground, it's a lot observational. It's a lot talking to people, getting the information, seeing things fit. But we've also got the forensic science part of it, which I'll admit over the past 30 years has gone from the greatest thing since sliced bread to highly questionable in specific areas of it. And I'll admit there are parts of forensic science that are pure science, and then there are other parts of forensic science that from a certain perspective are close to voodoo. But and some of those are getting taken apart at the moment. So things like DNA is science. There's no refuting DNA evidence. But things like handwriting analysis and other types of observational personal opinion type that at one point over the past 20 or 30 years were believed by juries to be, hey, if this examiner says it's true, it's true, to the point of, that's just kind of that person's opinion, isn't it? There's no science behind it. So it's forensics as a whole is going through the ringer at the moment. How much of it will come out clean on the other side will be interesting.
That's very interesting. Yeah, I always kind of thought forensic was kind of the end all be all of criminal investigation, but I guess it's not.
Well, forensics just is something that can be presented in court, science that can be presented in court. That's really what forensics is. DNA isn't necessarily forensics, but you could use DNA as forensics.
Gotcha.
But there's a lot of different branches within a crime lab that uses quote unquote science and scientific methods. We've got DNA, latent fingerprint impressions, firearms and tool marks, chemistry, trace evidence such as hairs, fibers, things of that nature, handwriting impressions. Trying to think of what other areas of the lab are, and they're, depending on which part of the lab you're coming from, is it true science and 100% sound, or is it a lot of personal observation and a person that's pretty sure what they're saying is true? If you can see it and it looks right, and you can convince a jury it's right, but is that science?
True. It's interesting. I heard of one recently that I didn't know even existed. The field of forensic accounting. What's that all about?
Yes, that's a fun game.
I have done fraud investigations, but forensic accounting is basically just crunching giant numbers to find where people are changing things. Yeah, because there's a course for being a certified fraud examiner and an investigator, and the main thing of that is just crunching large amounts of data to look for the anomalies.
See if you can spot any embezzlement and things like that.
Yep.
Yeah,
Gotcha.
So there's quite an interesting thing in there, and these are some of the really basic tests. Tests. Now, a good fraudster will know their way around it, but there's some issues with numbers and how people how people fabricate data. For example, if you start just randomly as a person, you start randomly writing numbers down. Let's say to 2 decimal places. Then what you can do to test if the data is organic or if it's actually false, what you can do is you actually just take the last digit in the data set and you plot the frequency of, you plot how often that last digit appears. So you can either, have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you plot a histogram of that. Now, there is a law which describes how often each number should appear. And if the data set is cooked and just fabricated by humans, then you will find that the number 7 and the number 3, now they start appearing more often than you would expect. And that's an easy way in which you can figure out, how books are cooked. Now, as I said, a good fraudster is aware of this, and they can, they've got other little tricks. But there are natural laws that numbers obey in organic systems, and if it doesn't follow these laws, then it's likely that that the books are cooked.
Very interesting.
That type of observation and examination of data sets isn't unique to just like fraud and money stuff. That can also be used to examine actual scientific data, because when you're going through a giant amount of data, somebody that's in that field will recognize legitimate data. But if you've got somebody who's trying to cook the books on their experiment, they can do the same thing. And I've heard a lot of researchers say when someone claims, especially like something in astronomy, it's like they fudge the numbers on this to get the results they want. It's like, well, but somebody who's an expert in that field will pick up on that those numbers aren't real. And the nice thing about science and fields of that nature are that the other people in the field will call them out on it. And every couple of years, you see something in the news about some researcher that was fudging the data to get the results they wanted. And as much as flat earthers and pseudoscience believers want to claim that science is a religion, not a method of study, then we wouldn't be calling each other out on the bullshit.
Well, that's absolutely true. The only issue with it is that it tends to be a really slow process. You can falsify data, but it depends on what situation you are in. So you can also see it happens more in certain areas than in other areas, right? So we see actually a troubling amount of that especially in social sciences and in pharmaceuticals, and that's really troubling. However, we do also see it in areas like physics, but the problem with a lot of this is that being found out is a very slow and painful process. So if you have someone just cooking the numbers in, say, a physics experiment where you have a massive data set, then, and if you're smart, you know how to get past those basic tests. But at first, it is down to the peer reviewers who will, review the paper and they go, well, this is not credible. And that should raise some alarm bells. And then that's where you get found out. But if you go past that, then you don't really get found out until someone tries to repeat the experiment. And if it consistently doesn't become repeatable, then you start asking questions. But especially in large, expensive investigations, this can take years, if not decades. So that is quite difficult. But on the other hand, we've got other situations such as you actually know, it's a great example. If we think about Andrew Wakefield and his falsification of data, that wasn't, and that's a small data set, right? We were talking about 12 participants in a study, and it wasn't found out that the data was falsified until about 10 years after publication of the paper.
He was hiding most of that data, though, wasn't he? That wasn't actually part of the research publication.
Yeah, it was. It was just a thing that there was just a focus on the bad methodology and a lack of repeatability of the study. And the big hoo-ha kicked off, and then it was found out about his ethical violations. And that was pretty much it, right? He was stripped of his medical license and everything, and he was told in no uncertain terms to bugger off. And it wasn't until after that when someone actually thought, hold on, what does the data actually, what did the data show? And because the bit that he falsified were symptoms and vaccination records and stuff like that. And the issue is that the real data could only be found in NHS records, and that is, difficult to get hold of, right? Is an individual's medical information. So that was really the difficult, because you need a standard to compare it to. Yeah. And because in the paper he says there were, I think he claimed that there were 9 cases of the participants showing autism, symptoms related to autism, and in the actual NHS records, it was only 1.
Gotcha. I guess maybe I'm just a little bit uninformed, but I always was under the understanding that if you had a sample size of less than 1,000, your data set was pretty much invalid or unviable. Is there any truth in that?
That depends on the test, because what you're doing here is, it depends on the test, the type of investigation, and the standard of evidence that you want to deliver. So in Andrew Wakefield's study, there were 12 participants, and that was a case control study, and that is not a really high standard of evidence that's usually employed to have a little explore, just to explore to see if there may be something that could be worth investigating using more rigorous methods. So you can have studies with low numbers of participants, but you just have to take that in account when weighing up the evidence.
You also have to really take that into account when you have a sample size that's that small, how you obtain that sample size, because it has to be a truly randomized, because with a data set that small, you can easily skew the numbers one way or another if you cherry pick where you get the information from, such as, like your child's birthday party, grab one of their friends that already looks sick, pay them money and say, would you like to be part of my study?
Mm-hmm. Yeah. So because these are all factors that you have to take in account when weighing up how good and how reliable a result is. It doesn't, a poor sample size which is not representative of the general population. It doesn't necessarily mean that it is bad. It just means that it may not have as much value as, say, a large cohort investigation involving thousands and thousands of participants, and it's nationally representative. So that is a better quality study. However, we must also be careful when considering really large data sets. Because, as I said, I work in this educational research group, and we've got a data set that comes out in whatever correlation we are testing. It comes out as significant, at least by some standards, because that is just what starts happening if you have a data set which, in this case, involves 200,000 participants. And then you have to redefine what it means for it to be significant. right? So in small data, in small studies where you say, okay, my p-value is less than 0.05, so I can treat it as significant. But in our case, we need to take a p-value of less than 1 in 1,000 for us to actually start entertaining the possibility that there may be something there. So a larger data set does not necessarily mean a better data set in terms of statistical significance.
Interesting. Well, thanks for that. I didn't realize there was so much that went into it, but it does make sense that you have to be equally as careful with a large data set as you do with a small data set. But it's equally easy to hide or miss something in both cases. Is that correct?
Yes, absolutely. And all of that, and this is why the statistical sciences are so damn hard. It's because all the rules change depending on your data set and what tests you are trying to perform on the data set. So, and even what kind of variables are in a data set. For example, if you are looking for if you're looking to find out something about how much what are the factors that determine someone's wages, and let's say we want to test education level, so we want to test income against education level. Okay. Great. Fantastic. Now, how are we going to do that? We can't just plot, income against education level and do a correlation because there's so many confounding factors. So you then have to start gathering information such as socioeconomic status. You're going to have to gather things like sex, race, location, because and then it gets more messy because it turns out that sex and education level, that there's an interaction there as well. So you need to figure out how sex and education level, how they are related before you can really control for them.
Yeah, and you also have to consider things like BM is probably very familiar with, occupations that get danger pay.
Indeed.
I mean, all of that will factor into your results.
Sorry,
but anyways,
I'm going to dip out for just a second. I have to feed the dogs, and I don't know if you want to listen to huskies howling at me.
No worries. Yeah, I guess we'll take this opportunity to check in with check in with Amy to see what's happening in the chat. You got anything for us, Amy?
I sure do, and I actually had some questions too, which is good. We've got Rune Thorsen says observational techniques is only the first part of the scientific method. You can't invoke science unless you got more than observation. And then he said mixing science with a court of law, not viable, not equal, false equivalency. And then Mandelbrot said it's weird how that works. People have been convicted on that kind of evidence. And then Rune Thorsen says, unless those fudging the data are aware, and this is taught in economics, so all the fraudsters know. Taddy Bogle asks, our own daddy, peer review should highlight if numbers data has been manipulated, yes. And then Rune Thorsen says, like the LIGO CERN staff, only 20 people can peer review it, and for them to find the key for the fudging, it is not really possible to find out. And he has that in quotes. And then he says, and then he asks, what's the relevance of the socioeconomic status here?
That's actually a good question, AB.
Okay, so in that example, socioeconomic status, it is quite important. There are many factors that impact socioeconomic status, and it's not just income. And so there you have a really nasty interaction there as well. He also made a comment about the LIGO CERN stuff, there being only 20 people able to peer review. That's absolutely not true. CERN involves 13,000 scientists, and LIGO involves around 2,000 scientists. There are a lot of people capable of peer reviewing, and that is only the scientists who are actually involved. They're not the be-all and end-all of particle physics and general relativity research. There are more groups out there and competing groups who do everything in their power to actually shoot it down.
Gotcha. So there's a lot more to it than just plunking numbers.
Yeah, and the data, the data is publicly available, and as part of as part of kind of good scientific practice, the data is accessible. It's either on a public website, or you can actually contact the authors and ask for the data, and they are expected to give it to you. Every time we publish something, we have an open data format file that goes with the submission, and that is made available, if not publicly, just as a download link on a website, or it is available in request. And if you ask for the data and we reject your request, we can get in very big trouble.
It may be a small number of people that can review the data as an entirety, that have the knowledge base to review the entire data set of what is being put out. But yeah, there's thousands of people that can evaluate their corner of that data that they're a specialist in.
That's a good point. Yeah, and being that it is public, the average general person out there who takes an interest in the study and asks for the data, how much of his input is actually taken into account?
Well, you can ask for the data, and then you can make comments on it. They'll be taken into account. But if you're just requesting the data and then you come back with, no, it's all fake, then you're not going to be taken serious, right? You need to have legitimate, you need to express some legitimate concerns and back it with good reasoning.
Exactly. And that's, I think, the biggest problem we have with the conspiracy theory community. They often misapply or misunderstand what research is really all about.
Yeah.
And one thing that's great nowadays is that, you make the comment of what happens if somebody comes back and says, no, it's all fake. But there are areas, specifically like in astronomy, where their data sets aren't just public, they're crowdsourced. So if you go to, I think the website's Galaxy Zoo, they are asking for regular everyday citizens' help. Some of the projects are identifying types of galaxies and images, identifying types of craters on the Moon and Vesta, identifying craters on Mars. What else? The light curves from God, now I can't think of the satellite that was found the majority of the exoplanets. They're out there. They're crowdsourcing because it is such a large data set, and they have computer scripts that will run through the light curves to try and find exoplanets. But they know that people have a better eye than script that can see nuance, and they're asking everyday people to review this. And no, they're not just going to take my personal opinion, just mine, that yes, that is an exoplanet around this star. They're going to have 100 other people evaluate the exact same data. But it's out there, it's public.
Yeah, and it brings up a good point, because I was going to ask you about the rather active public input you had on your Cavendish.
Oh yes, I had so much input on that when I built that together, and a lot from AB. And half the time I'd had to ask him 3 or 4 times, dumb it down a little bit more, dumb it down a little bit more, little bit more. Talk to me like I'm a 3-year-old. Yeah, I had a lot of public input on that to try and make sure it is robust of an experiment as possible.
You got some good results too.
Yeah, it was a great experiment. I hope to rebuild it someday.
Yeah, I
Maybe a
hope so
little more
too. Okay,
stringent in
great.
parameters.
Yeah. Well, I think I'd like to also maybe ask both of you about the psychological aspect of the research you're doing. AB, you said you were into educational research at the moment. What are some
Well,
of
no,
the
that's a side project.
psychological? Oh, okay. But still, what are the psychological implications that are going to affect your results?
What's going to affect my results? Well, it's the psychological stuff. It's not going to affect my results. It's going to affect my interpretation of the results, isn't it?
True.
And the thing is that if you're performing research, you tend to be very eager to kind of get your results and show, yeah, I've done a thing and it's awesome. You have to be mindful of the data in your interpretation. And when you shout eureka, you have to be absolutely 100% sure. So on that side, it's really hard because you get your results and the temptation is to shout, yes, I got it. But your actual response should be, what have I done wrong?
Yeah.
And
Exactly.
And that is the first thing that you need to do. Ask yourself, just assume that you are wrong. Assume that you messed up somewhere, and until you can no longer defend that assumption, and you do this by testing, and you just try and break the result. And once you're in a position where you can no longer defend your assumption that you are wrong, do you start accepting the result?
Gotcha. And that leads me to you, BM. As a criminal investigator, a big part of your job must be being able to read people on a psychological level to validate the information you're getting.
That's something you really can't teach too much. And it's honestly something you should not rely upon, I would say, because it might get you information, but my job doesn't end when someone confesses to me because for whatever reason. I need to be able to prove the facts of the case, regardless of whether the person I'm looking at actually did the crime or not. I need to know the facts of the case and be able to validate that at court. So there are certain people that are good talkers. There are certain people that aren't. I'm not the greatest subject interviewer. I like to believe what people tell me. I'm not a confrontationalist when it comes into that area. Most of the confessions that I've got have been, I'll say, on accident, because, I was about ready to say, okay, I believe you, and then they've just like, oh man, I feel really bad lying to you, and then they open up. But the psychological aspect of trying to read people, yes, some people can do that, whether it's valid or not, I don't know. But our goal always is pretend the subject interview never happened. Pretend the confession never happened. Still prove what the facts of the case are. Because if you just go off of that, there's a lot of gray area that you could argue was the information elicited because of you or because that's what really happened. And the topic of false confessions is a sensitive one. People on both sides of the argument, all confessions are false or no confessions are false. My opinion of it is that let's pretend that the confession never happened. Validate everything else that people are telling us.
Yeah, base everything on the evidence you've got.
Well,
Yep.
because that makes me think, right? Because it's pretty well established that eyewitness accounts and confessions even are pretty sketchy. They're questionable at best. So is it then actually are you then just in a position? When you do your thing, do you just disregard the any eyewitness testimony, any confession, or to what extent is it a useful pointer in how to carry out your investigation?
That is really what it is. It's a useful pointer. It's you don't disregard it, specifically for a confession. Like I said, my mindset is pretend that never happened. Validate the information that was told in there. But let's assume that this guy is the bad guy. He's the guy that did whatever. When I go to court, what he told me in that room, pretend I can't talk about it. I've got to be able to validate everything else, the facts of the case. You can use what they said as a pointer to go in different directions, but you never take just what they said at face value. And that goes both ways for inculpatory and exculpatory evidence. Because you'll see investigators that when the bad guy tells them the things that are damning, they verify the damning stuff. But they don't verify the non-damning stuff. And we've got to be able to, as an unbiased party, we've got to be able to do the same thing.
That's why the legal system is based on innocent until proven guilty.
Yes, and it's hard as law enforcement to remember that because you want to get the bad guy, but you still have to validate the information. And I've had cases that the guy was probably guilty. They gave us a partial confession, but we couldn't validate anything else, so the jury went on their side. Now, that could be viewed as a ding on us because we couldn't prove everything. But if you can't prove it, you can't prove it. And you can't make assumptions and things like that.
That kind of mirrors I think that's unique within Scottish law is as opposed to just guilty or not guilty. We have a third verdict available to us in a jury trial, whereas the charge is not proven. So we're not saying you did it, we're not saying you didn't do it. What we're saying is that the prosecution has failed to prove the case, so therefore you're exonerated. Is that the kind of thing you're talking about?
For in the American judicial system, it's guilty and not guilty. Basically, that's if it's not guilty, it's kind of the same thing. It's that the prosecution has not proven their case. It's opinion whether that means they didn't do it. Not guilty just means that prosecution couldn't prove the case as argued. But once you've gotten that not guilty verdict, case is over because it can't be retried.
Yep.
So you walk away scot-free.
Yep.
Cool.
Okay.
Just think it's a kind of basically just a variation in the grading.
Yeah, but isn't that issue then just what that third verdict actually addressed that because you can't retry a guilty or a not guilty. Well, you can appeal a guilty verdict, obviously, but if you're but it kind of opens up a bit of leeway. The jury thinks actually you are guilty, but you can't prove it. So therefore, it just opens up a little bit of leeway, so it can be revisited if more evidence comes to light.
Well, it looks like things are getting a bit exciting in the chat. And Amy, what have we got?
Yes, we do have some good things in the chat. I've got Rune Thorsen says, I have the LIGO data, terabyte worth of it. Who can interpret it, though? Have you tried interpreting it? Mandelbrot says, can you explain margin of error in a poll? The reporters always get it wrong, and I don't remember the equation. Rune Thorsen says, this is a tip of the spear, compartmentalization. You say 13,000 scientists are involved in LIGO CERN and can peer review the data. That is how they do it. You will see perhaps, perhaps not. And then Mandelbrot says, do you remember that time that they announced that neutrinos are traveling faster than the speed of light and it turned out to be a bad computer cable?
It's not as embarrassing as the baguette.
The what?
The baguette. So on the first run of CERN, I think it was the first or the second. I can't remember which one exactly, but they tried turning it on and it didn't work. And they reckon it is because they found a baguette in the apparatus. And I think it must have fallen through or somehow. I don't know how it got there, but that was a big fun one.
I never heard of that. That's funny.
Yeah.
Cool. Well, I think maybe for the benefit of those in the chat who might not be qualified research scientists like you guys, can I ask you both to kind of give me a rough idea of your definition of what research is? AB?
For me, it's quite straightforward. A research is the act of investigating something whilst it's the act of trying to investigate something to minimize doubt, and in a way that minimizes human bias. And that's it, really.
Okay. Now, how about you, BM? How would you define it?
Well, for me, it's weird because most people wouldn't view law enforcement as a research, but it really is. It is research into events of life. It's not necessarily research from my end of it. It's not research into science. It's research into an event. So you're researching different people's observations. You're researching obtaining data from other sources, such as, security camera footage, from audio, from photographs, stuff of that nature. But me, for the scientific side of it, and I am not a scientific researcher at all, but one thing I think that gets confused a lot is, especially with flat earthers, is that it's not research if you can't wiggle one of the variables.
Yeah.
No, that's not true. That's experimental research. There's a difference between experimental research and observational research. And just because it's purely observational doesn't make it not science.
Mm-hmm. So you're dealing more with applied research.
Yes.
Whereas AB, you're more into the qualitative, quantitative research. Is that right?
Well, so we've got to differentiate between qualitative and quantitative. Just a few. Quantitative research just means that you can attach values and numbers to your predictions and your results, and you can quantify how well your results match your predictions. Qualitative is more about. It's more about, do we kind of see what we expect to see? So, for example, if we look at Sleeping Warrior's egg experiment, the way he did it, he didn't really measure anything. He just went, okay, does the egg float or sink? Mm-hmm. That is qualitative, right? Mm-hmm.
Exactly.
The way I repeated the experiment and actually tested very clear hypotheses. That is quantitative, because there was an actual empirical and there was a hypothesis test, where actually went to see if we exactly get what we expect, and that becomes important because sometimes you can end up in a situation where you cannot actually distinguish if you just do things qualitatively. You cannot distinguish between whether your null hypothesis or your hypothesis is correct. And to take Sleeping Warrior's experiments again, if we think back to the one where he put the magnesium in the conical flask and burnt it, and the plunger went up and stuff like that. Again, it was a qualitative approach. And it really highlights the importance of being able to quantify things and using mathematics, because his hypothesis stated that there would be a 23% change in the volume that's inside the containers, and that's that wasn't his hypothesis. That was the conclusions that I drew from what he is stating. But then established science, the established theory says there's a 21% change in the volume. And just taking a qualitative approach, in both cases, we expect the plunger to go up. But which one is right without measuring something? Because as a human, you can't tell the difference between a 21% or a 23% change. That's it just doesn't work that way.
Are you saying the eyes aren't calibrated good enough?
Turns out, yeah, they're not.
Yeah, they're pretty shitty, actually.
Yeah.
Which is kind of funny, is that's the majority of flat Earth, quote unquote, research is you have to use your senses. You can't use anything else. You have to use your senses. That's why we don't see the curve. That's why we don't see the horizon rise to eye level.
Yeah, and that's why they keep getting the wrong result.
Yeah, the human senses aren't calibrated enough for that small of a change.
Absolutely.
Yeah, exactly.
That's why we
then-
design experiments and equipment to do it.
Yeah, exactly. And that kind of leads to my next question. What level of research design is applied to each of your fields?
Oh, what level of design?
Mm-hmm.
It depends on
In
how you
your
look at
case,
it.
it would be a lot. I would guess.
The principles are simple, right? We have a working theory, and we can push the boundaries on that theory and make predictions. We can say, right, so there's a relationship. So if A is true, then B is true, and it's because of this mechanism. So if we take that as true, then we can look at that mechanism and then say, all right, so that mechanism is in place. What other predictions can we make? Right? What other predictions can we make? And then see if A leads to C or B leads to C or another one. And so there we have, based on the theory, we have another prediction which is untested, and then we go and test it. And so that's kind of like your first step. What are the boundaries of the established scientific theory? And let's go and test it, because all the stuff that we know and tested and have repeated, this is not going to tell us much, right? Because then we're just looking into stuff we already know. But if we then push the theory to its limits and then test that, then we are in an area where we can try and disprove the theory, and that's where we look at in physics. But in physics, the design, the principles behind it are very simple, and this is why in physics, in like the social sciences, for example, there's a lot of time spent at undergraduate level in teaching research methods and stuff like that. If you just Google research methods, then most of the time you'll get information about from social sciences or psychology, where outlining these, because there it's a complex topic. In physics, it's really straightforward, because as physicists we do lab-based controlled experiments. You have an independent variable, you wiggle that, and you see what happens. That's great, and that's how simple it is. But yeah, as I said, it's not that simple in psychology or in social sciences.
Yeah, the amount of hits I got when I put in that search in Google was business. A lot of business research results came up. They're really big on the different research methods for all kinds of things, like market research and product research and all kinds of things. And it's really quite in depth.
Yeah, absolutely. And that's because these are all observational methods, and they are difficult and they are complex, right? They're not as simple as just, I change a thing, something happens, let's measure it and see if it matches with our prediction. It's a lot messier, because we don't have, like, in physics we have an equation, right? We come out with an equation, and we change our independent variable. We see a change in the dependent variable as predicted by that equation. So we record that data, we then plot it, and we try and fit that equation to the data. And depending on how well it fits, we go, yay, result. Now, in the social sciences, or in the statistical sciences, you don't have that equation. You don't have an exact equation to exactly tell how one thing leads to another, because turns out, humans are quite complicated.
We are. No, really. And that kind of leads me to you, BM. Is there really much research design involved in what you do?
So from me on the ground level, not necessarily the design of the research. A lot of what we do is observational at a scene based upon previously done research. So like blood spatter analysis. I've been through the course, but I have not done. I'm not the one who had to go back and figure out angles of impact to determine how, the speed and angle that it's coming from. Other scientists have done that over the last 30 years. What I do on the scene is identify spatter that I want to examine. I examine it, and based upon its length, width, different variables, I rely upon the research that's already been done to determine where that particular droplet came from.
Gotcha.
And that to me is a pretty sound research, because that is blood as a consistently viscous fluid that you can generally say where things came from and what the general speed of it was, because you're trying to recreate where did that come from. And another area that we do a lot is bullet trajectory, determining where was the shooter standing when they fired. I've done that multiple times, and it's one particular scenario. I'll try not to get too graphic, but it was a death by suicide. Female had shot herself, and that doesn't happen often. And when we walked up on the scene, it was a male in the residence and a female that was dead in a closet. And that doesn't say to us suicide. That says weird circumstances.
Yeah.
And that is our internal bias showing there. But through examination of trajectory, we even had the law enforcement that found her come back into a similar residence, because it was an on-base residence, so they're all exactly the same. So we went into another clean residence, and they showed us how they found her. And through that method, we were able to determine that this 6'4" guy couldn't have done it. But from where she was sitting on the floor, she was looking at him when she did it.
Oh, interesting.
Yeah, so that was one of the rare occasions where we were able to directly identify on the ground how something specifically happened. The guy was still a bad guy, just not a criminally bad guy. So that's the type of stuff that we do on the ground, and it's based upon other people's research, which, according to pseudoscientific logic, I can't rely upon that because I'm not the one that did the blood spatter research, so I can't use it. You have to have done everything yourself.
Yeah. That brings up actually an interesting question. As you said, you do everything on the ground. You're on the scene just shortly after the event took place. How much impact is there on the degradation of the physical evidence on the scene? Because over time, blood will deteriorate and so on. I mean, you have a limited time frame in which to do your research. Science on that end is getting a lot better on able to identify, because they're able to even find touch DNA. So like if somebody patted you on the back, if we're able to get your clothing, they're able to get touch DNA several days after the casual contact. But the biggest thing, it's getting impressive. So like for sexual assault forensic examinations, when I first started this, if the event was more than 72 hours ago, they're not doing a kit, because the belief was that we're not going to be able to find DNA. Now they're doing them up to 7 days. Wow.
Yeah. The biggest confounding factor for us to identify evidence and collect it successfully on scene are the other humans that have been in the residence or in the location since then. That's why for us, the security of the scene is the biggest thing, and you have to keep people out. Once we're on grounds, like nobody's coming in, because it's the Locard's principle of transference. Every time you interact with an object, you leave something of yours behind and you take something of it with you. And you want to minimize that to the most possible extent, and then identify everyone else that's been there so you can get samples from them as well to exclude them, because I know you've been here afterwards, and I don't want to think you're my bad guy for 6 months and go chasing a ghost DNA for 6 months.
So kind of exclude them from the equation right at the start.
Yep. Yeah, but it's how long we're able to get DNA is getting more and more and more impressive. It's really it's interesting how long, and as it's a constantly changing field as well, whether they will or not, and what they can examine.
And how about you, AB? Do you ever have any instances where your source material or whatever has degraded, where it's no longer useful for your research?
Well, absolutely. That is one of our biggest problems. So I work in nanotechnology. We are building things at the atomic scale, and there's absolutely a lot of degradation. We have to build things in a class 100 clean room, and that is to say that for every cubic meter, we are allowed to have no more than 100 dust particles. Now, out in the open, it's orders of magnitude larger. Then we have to do things in ultra high vacuums, to build things and to prevent oxidization. So, we're dealing with a lot of metals, and if we have the metals for too long, if we have our samples, if they're too old, then they degrade because they get rusty and stuff like that. And because we deal with magnetism, iron oxide has entirely different magnetic properties than the iron I normally use, or the permalloy. So yes, we do have degradation, and we do have samples that just go bust, right? So we stick, I'll stick a sample in. If we're working with particle accelerators, for example, we stick our samples into targets and bombard them with X-rays. If we have our exposure too high, or if we've been at it for a bit too long, the particles, the samples will melt and become absolutely useless. And that's also one of the points that I alluded to earlier. Is when we get a result that looks great, then the question we have to ask is, what did I do wrong? And a lot of the time, it just means like, oh yeah, it's melted, or the sample is just no longer functioning. Even if we just if we stick something in an electron microscope, for example, we can sometimes see the physical. We can actually physically see the samples deform, and the structures we make. We can see on the camera. We can see them melt and just collapse because, just because they're being bombarded with electrons.
Exactly. Well, let's check in with Amy again. Is there anything interesting in the chat, Amy?
Oh, there definitely is. Let's see what we've got here. We've got Ugly German Truth said it is one of the two contradicting main axioms of FLIRF. One is only trust your eyes. The other is your eyes are curved, so they cannot show you anything straight. Biggleson says, I work in research in human factors and ergonomics, PhD professor. I agree that humans are complex. Rune Thorsen says, statistical sciences like economics are all about reaching equations, sure, but not physics, LOL. In physics, the equation is your linguistical expression for reality. Mike Bertelson says, if I want to build a concrete canoe, Riley egg demonstration is useless, but with AB's egg experiment, I now have enough data to at least begin creating a working design. And science and engineering need the quantitative research for practical application. This isn't to say that qualitative experiments aren't useful. And then Biggleson comes back and says, I object to the existence of quantitative research versus qualitative research, only different types of data to use. And then Ugly German Truth says, when will FE bring their own alphabet and programming languages and electricity? You have to do everything by yourself is a stupid maxim, even if you take it with a grain of salt. And Bullionator says, contamination is a huge problem with clean rooms.
Absolutely, it is. Absolutely.
Yeah. And that's probably also a really, really big concern for guys like UBM, because keeping that crime scene free of contamination must be a huge challenge.
It is. And then bringing the evidence back to the lab. Basically, the rule of thumb for us is if you collect it on scene, you package it on scene. Because God forbid if it's a sexual assault and you collected both of their clothing from his room, her room, they weren't together when you collected it, but then you bring it back to the office and lay it out on a quote unquote clean table. lay one out, take pictures of it, lay the other one out, take pictures of it. Now you've just nullified any transfer of DNA, because the argument could be made that it happened at your office, not during the event.
Gotcha.
And from the psychological aspect of it, this is kind of a different tangent, but I accept the fact that everyone I talk to lies to me. That's kind of my job. The subjects lie to me, the victim lies to me, everybody lies to me. But when you're talking to a victim, and this is something that I try and preach anytime I do these victim interviews, is I need as much honesty as possible, because I don't want to find, if I find out things later on, it makes you look dishonest, and nothing you have done can make it okay what happened. And the biggest thing is, like, again, for a sexual assault, who else have you been with over the past week? Because I'm going to collect the DNA, and I'm going to collect it from the accused as well, either through a warrant or through consent. And if I come back and the sample isn't his, or it is and someone else's, that makes you look like you're hiding something. And it doesn't matter that you had sex with your boyfriend before or 2 hours after. That's a psychological question that we can put somebody up on the stand to describe, because people who've been through a traumatic event want to go back to the norm. They don't want the last person they were with to have been by force. But if you don't tell me, it looks like you're hiding it. And I can't tell you how many times we've gotten the kit back with an unknown sample. And it's like, all right, now we got to go back and figure out where that unknown sample came from. Doesn't make if the crime happened, a crime happened. It doesn't make any difference. But it kicks in that psychological aspect of doubt for the person that's making the allegation.
Yeah, absolutely. And that leads me to my next question, actually. When we are talking about the research as done by conspiracy theorists, what are some of the biggest problems that you see and biggest annoyances about how they present their so-called evidence?
Well, for me,
the biggest thing is cherry picking. I would have to say, massive amounts of cherry picking.
Yeah, for me, it's let's just I'm just going to ignore the cherry picking and everything, and just assume that they're actually doing a test. What a lot of the conspiracy nuts, and to be honest, most of the general population don't understand, is that when you are performing the experiment, you're actually wiggling your independent variable and you're recording your dependent variable. That is not where you test the hypothesis. That is just gathering your data. Your hypothesis test actually happens at a later stage, and that is the point where you actually try and fit an equation to your data. So you're gonna have your prediction, and you have some data, and you then actually fit that equation to your data with different parameters, and then the result of that, you compare that to what your hypothesis says should happen and how well those match up. That is where you test your hypothesis, not what's actually doing the experiment. So if you are just going, there's some salt added to the water, egg starts floating, and that's my hypothesis test done, great. No, you've missed the analysis stage.
One other area, I want to ask AB this if he's ever seen it. One other area of research is, if you're honestly trying to do research, is intentionally trying to prove your own hypothesis wrong. You have to test it as hard as you can. Have you ever seen a flat earther do that?
Well, that's the thing, because, and this goes into the fundamental idea of proving things, right? I mean, we say you can't prove anything in science, and this is perfectly demonstrated in what a hypothesis test is. Because all the metrics that actually come out are measures not of how well it fits your hypothesis. They're actually measures of how badly it fits your hypothesis. And everything at the analysis stage is actually designed, and all the metrics that come out, it's designed to disprove your hypothesis. And this is why we sit on the edges of science. of the theory and test that, because if we can disprove the hypothesis there and assume that all the maths that took us from the theory to our hypothesis, assuming that that is correct, if we can then disprove that hypothesis, then logically we have demonstrated that there's something wrong with the theory. And that is every scientist's dream, because we want to disprove the theory, right? If you look at every test of special relativity or general relativity, it is not there to prove it, because from everything we've seen so far, it works, and it works really well. We're actually trying to disprove it.
You're trying to find the edges.
Very important. Yeah, you're trying to find the edges of it and find where it falls apart, because then you access new physics. And then you access new ideas, right? Because there is no money in investigating stuff we already know.
Yeah.
If you're going to take these...
Yeah, sorry. I don't mean to jump on you, but it seems to me like that's exactly what this Apophis dude is doing. I mean, he's going out finding all kinds of stuff that fits what he believes, doing virtually nothing to verify it or analyze it, and presents it as fact, and that just drives me insane.
Well, that's the thing. I mean, because for example, if we take his example, his approach to science, and you see this a lot in Flat Earth as well, is they take, let's just take a nonsense hypothesis, right? Stuff falls because of unicorn farts. Right. So if you want to make that claim, and if you want to verify that claim, what you have to do is first demonstrate that there is such a creature as a unicorn, and you have to demonstrate that they have an asshole, and you have to demonstrate that they can expel gas from that asshole. Then you have to demonstrate that actually that gas results in stuff falling. So you need to test that. So you stick a bung in the unicorn's asshole, and then stuff should stop falling, right?
Mm-hmm.
Now, and these are all the steps, but let's just take the hypothesis: stuff falls because of unicorn farts. So you pick an object up, and you drop it, and it falls down. And then they go, yes, there you go. See, stuff falls. Therefore, it's unicorn farts. It's like, no, that's not what you've demonstrated. All you've demonstrated is that stuff falls. You haven't demonstrated that it is because of unicorn farts. So
Exactly.
Yeah.
What do you think, BM?
I love that entire breakdown of it's simple to observe that, and it's simple to grasp and to understand the layers of the examination you need to go through if you want to actually test it. You can't just take a premise like that unless there is some kind of scientific research behind it. So if you want to claim that that's what it is, it's great. I love that you have to go back so far to start proving things. But then that also brings up the question that flat earthers are saying, is like, well, you never prove that unicorns exist. It's like, well, with everyday research, I don't have to prove that the sun exists. I don't have to prove that it makes me warm. Those are things that we've already proven and accepted. I don't have to start my research there.
Well, absolutely. I mean, the example I've given, that is, and that applies to if you're trying to present an alternative, right? We've got the whole scientific theory. We have the framework that's there. We've demonstrated that exists. So, for example, we can take a lovely example of, say, special relativity. So we established, a few things around, the framework was developed, and it makes sense, and we can test it, and it makes sense. Okay, cool. So we've confirmed that bit, and that is consistent with what we observe. Fantastic. And now we take it to the extreme. So then we can look at things. Okay, what are the implications of this? And then you can come up with, oh, right, okay. So if we investigate this, if this is true, then we should see things like antimatter. And okay, cool. So there's a prediction here. Special relativity with quantum mechanics predicts that antimatter is a thing and it exists. all right, let's test that. And turns out it does exist. And then, I think it's about 60 years since then. But now we use that stuff on a daily basis in diagnostic medicine, and that's that whole progression. Now, if you want to posit an alternative, if you want to say the ether, then first you're now in a position where you first have to show that the ether makes the same predictions as the original formulation that Einstein proposed, and then you have to also show that it can predict antimatter, because we know it exists.
Cool.
I think a good example of this was the switch. Or I can't remember how Riley put it, but when science went from the Newtonian view of gravity to the Einsteinian view of gravity, the base level of the cause was different. So you can't just start at the surface with Einstein. You have to go back and prove that the basis for why Einsteinian gravity occurs is actually there.
Well, you have to then also do something else, and that was the very first thing that Einstein had to do. He had to show that because we've got Newton's universal law of gravitation, right? We all know it, minus gmm over r squared. He had to show that his equations reduced down to the same equation as Newton's laws. And there's a derivation. It is pretty standard, but if you apply the limits to what we observe and where we are in the universe, and if you apply those limits and those conditions on it, then you do indeed see that Einstein's equation, that the metric, as they call it, that reduces down to the gravitational potential that Newton described.
Very, very interesting. All right, well, let's see what's going on in the chat. Amy, is there anything new?
Yes, there actually are. You Ugly German Truth says disproving relativity would be great. If we'd never gotten around to show where Newtonian gravity doesn't work, that next step would never have followed. So finding the kinks in Einsteinian relativity means finding the place where the next level of knowledge needs to be footed. Ugly German Truth then again comes back and says, if you plug up one unicorn sphincter, the reason for stuff falling could still be any other unicorn being flatulent. And then Roger Rabbit had a good comment too. He says, when A and B occur, then A might be causing B, or B could be causing A, or C could be causing both A and B, or A and B could be unrelated.
Well, that's very true. If you're so if you're doing statistical methods, and that's why it's so difficult to do that. If you're doing a classic controlled experiment, you can actually kind of tease that apart, and that's why they say in experiments you can actually establish a cause and effect. However, just because you're doing an experiment doesn't mean you can establish cause and effects, of course, but a well-performed experiment that takes account of everything, there you can do that, and you can show which way round it is.
With that, the A and B resulting in C, there's a website, Spurious Correlations, and it shows you where you've got that A and B that correlate but have nothing to do with each other. They've got a list of crazy things.
Oh yeah. It's Tyler. I can't. Yeah, Spurious Correlations. Google that. It's funny.
U.S. spending on space science and technology almost exactly correlates with suicide by hanging, strangulation, and suffocation.
Yeah. But that's also what I alluded to earlier. It's the issue when you have large data sets, right? You can correlate almost anything, and you have to be very aware that if you have a really large sample size, that can happen.
Yeah, the number of people who drown by falling into a pool almost exactly correlates with Nick Cage movies.
Well, I think that there's a cause and effect there.
Could be. All right, and I saw one in the chat that I'd like to bring up. Mike Bertelson, he says, Matthias the Walking Witness says, apples fall and helium balloons float. Thank you, Dr. Obvious, the world's foremost authority on the incredibly apparent. Not evidence of anything.
I thought that was a result of the force of uppity.
Yeah.
Oh wait, no, Subaru's called it levity.
Yeah.
Well, that is just plagiarism. I mean, that was Douglas Adams. The opposite of gravity is levity.
You know how to fly, don't you? According to Douglas Adams.
Yeah, just throw yourself at the ground and miss.
Yep.
That seems pretty straightforward to me.
It is, yeah.
So let's see what we haven't heard from Taddy in a while. Taddy, what do you think of all this?
No, it's just I'm just sitting here and my mind's absolutely boiling at this point in time. To be honest, just that much information coming through. It's just like, wow, kind of opens your mind a wee bit. What I would like to know is what's the difference in the two methodologies between BM and AB with how they go about with the research.
That's a good question, guys. What do you say?
Well, I would say it depends on how you tear it down, right, and how you break it down. Because both approaches, we go with, we have a hypothesis and we test, and we see, we take a hypothesis. If this happened, then this should be the case. And we both test that. I mean, the methods are a bit different, but yeah.
Yeah,
Cool.
the methods behind forensic science should be generally similar and just as stringent as standard science. You should be repeatable. So again, that's the lab side of everything. That's scientists and coats doing DNA, fingerprint analysis, blood spatter, where they're examining how blood works or how it interacts with the environment. Me on the ground, I would almost say that my aspect of it is a little more psychological research than experimental and physical.
Yeah. Well, from a layman's point of view, would I be correct in saying that AB, you're more into the inductive research, whereas BM, you're more deductive? Would that be a fair statement?
I don't know. I can't comment on Furball's approach, but yeah, I mean.
Cool. What about you, BM?
I would say yes. Furball?
Yeah, I would like to say yes, but I'd have to do a little more thought process on that because it's a bit of blending on both sides almost.
Yeah, I can see that. Cool. Well, I don't really have any more questions. Is there anything else you guys would like to bring up that we haven't covered yet? AB?
No, I just wanted someone in the chat brought up dark matter, and this was in reference to kind of testing all that. When I was talking about testing for general relativity, and this is a fine example of where the theory is being pushed to the edge, right? So we have this prediction, dark matter, and we're trying to find, if it is consistent with reality, and we are trying to figure out if dark matter is a thing. And there's a bit of a common misconception that dark matter is the established viewpoint in science, and that is a thing. Firstly, there's a lot of work being done to develop alternatives to general relativity, which do not require dark matter. But as it stands, general relativity with dark matter, it is our best candidate. But we're not quite there yet to consider that as a proper part of the theory.
And BM, do you have anything you'd like to add to the discussion today?
No, I don't think so. Science is just so amazing to me. I mean, evaluating everything that's around you, but doing it in a strict way that is able to give you valid information and not selectively incorporating just the things that agree with yourself. Like we discussed earlier, if you can disprove your hypothesis that's kind of the goal of science. I mean, that is on the edge of what every scientist truly wants. They want to find some new area to discover.
Yeah. And refine or improve what they already know by disproving it.
Yes.
Sounds kind of counterintuitive, but that's actually what's going on. Okay, well, I guess that just about finishes it up for today. I'd like to take this opportunity to thank both of our guests for coming out. It's been an awesome discussion. And before we go, let's check in one more time with Amy to see what's happening in the chat.
Sure. I have some good ones. Rune Thorsen said, it is the only proposed solution to the galaxy rotational problem, right? And then, and that's pretty much it right now. That's the last of them.
So
Right.
dark matter is not the only proposed solution. We do have Eric Verlinde's entropic gravity. We have several other frameworks that are being developed, but none of them have the predictive capability of general relativity with dark matter at this moment in time. And that's just simply the case. These alternatives are being investigated alongside with general relativity. That's just how it sits. But as I said, you have to first demonstrate. It's like, okay, so say entropic gravity, for example, it could address the issue of, it could address the issues of the rotation of the galaxies and not require dark matter. But there are a few other things that it needs to predict and accurately predict to the same extent as general relativity. And at the moment, it still doesn't quite do that. So it is not as good as the solution of general relativity with dark matter. So if we find a way to kind of measure dark matter and confirm its existence, that will be great. But we are not at that stage.
So basically what you're saying in layman's terms is it's our best guess so far.
It is our best guess so far. And and that's it. But these alternatives are, being proposed and being developed, and there's a lot of funding going into that.
Do you have any particular beliefs on what you think it will ultimately become or identified as?
I to be honest, I don't really know much about it. I'm not a space guy. At the moment, I think Eric Verlinde's is the most promising one, I believe, and that's not going to work out well for Anthony Riley, because in there gravity is a force. But and not an inertial force like it is in the general relativity framework. But I'm not a cosmologist. All of that, it's quite tricky.
Yeah, it's a big question. It's going to take a long time to answer.
Absolutely. But as it stands, right, we know that general relativity, that it is an incomplete theory. We know that. And we've been trying to disprove it. We've been working on that, for 100 years. We've been testing it and trying to disprove it. We know it's incomplete. The theory itself predicts that it is incomplete. And we're just waiting for the moment where it falls down, if it's with dark matter or with something else. Possibly, there'll be another issue. We don't know. But we're working on it. And, a lot of people are dedicating a lot of time to figure this out.
And with that, let's say we go around the room, get some final thoughts. Let's start with you, AB. Any final thoughts on today's discussion?
It's been a good chat, and I look forward to doing a bit more.
Yeah, well, we look forward to having you on again in the future. And BM, do you have any final thoughts you'd like to share?
Research methodology is an area that is rife for discussion because different people will have different views on how you should research anything, and it is an area that needs to be discussed. It's an area of science that should not be put in a dark corner and said, no, this is the way we do it. Because when you do things in a specific way, just because that's how we've always done it, you're guaranteed to fail. So
Yeah.
the way research is done should always be discussed, and it's fascinating when people come up with new ways to try and get at the data. And it's fun to watch.
Absolutely. I agree. And Taddy, do you have any final thoughts of what you have witnessed today?
Yeah, no, it just goes to show that when scientists release their findings of experiments, etc., they don't just pull these figures out from anywhere. There's a lot of work and a hell of a lot of thought goes into the background and the groundwork and the spade work before the general public's even aware of the kind of things that they're looking at. And it's easy just to turn around and go, well, you know what? That doesn't make sense. Nah, I don't believe that. I'm sorry, man. The facts and figures are there, especially when it's peer-reviewed and the findings are correlated and found to be correct. There is no argument. So I don't understand where folks are coming from.
Yeah, well said, well said. And you're right. I mean, the facts are there. You just got to be willing to accept what the facts for what they are, and be willing to change your viewpoint if something new comes up.
Exactly. There's nothing wrong with being wrong.
Yeah, exactly.
Well,
That's something that's...
all science is based on that, right? Scientific theory is our best description of nature. It doesn't mean it's right. It's just our least wrong one.
Exactly.
There is one major downfall to being wrong, though, and that's being wrong while spending someone else's money, which is a huge problem in science of non-publication of, experiments that didn't come to fruition, and trying to get people to pay for your research when your methodologies have previously been proven wrong. That doesn't mean that you're doing anything wrong. It just means that we need to adjust. But spending somebody else's money on something that is proven wrong can be a dirty area of science.
Yeah.
So this is a big problem, and this is called the file draw problem. It's just uninteresting or null results that don't get published, and there's a whole aspect side. There's the whole business aspect, because you've got to remember that scientific publishers are businesses, and they're not interested in publishing null results, because a journal is measured, the quality. One of the key metrics is called the impact factor, and that's a ratio of how many times the articles are cited. So and null results don't get citations. However, they're good to know. So there are a few, and this is a big problem. However, the European Union has just announced that they will actually launch their own journal where actually null results will be available, and it will be an open access journal where there's no paywalls or anything, and the standards, the papers are not judged for the actual results, and they're judged on quality alone. Because this is a big problem, especially in the pharmaceutical industry. It's really bad what's happening there, because what you can do to test a drug is actually you actually launch several trials, and just by sheer chance, a few of those trials will actually show a significant result which is favorable to the narrative. So you publish on them, and you don't publish on the other trials which show that there's no result. And this results in a skewed picture of how well the new drugs actually perform. But it means that the pharmaceutical company can file a patent against it, even though it doesn't actually outperform the established the established treatment. But by doing that, they take the established treatment off the shelves and they bring the new treatment, which, you know, does just as well. They can just hike the price of that, and they can keep the patent on that, and they can prevent the cheaper knockoff versions of coming to market.
Yeah.
And that's problematic because we're now in a situation where, you know, the price of medications are just too high, and if you are in countries where you don't have universal healthcare, then you know, the prices are crippling.
Yeah.
And there are again incentives being put in place, because you have to think about the alternative for a pharmaceutical company, right? Because if you don't publish your null results, then that's fine. You as a company don't, you know that doesn't work. But the other companies don't, and they will invest in research into those drugs. But if that information was out there, the other companies wouldn't have to invest money in that drug because they know, okay, that is not going to work. Now, if every pharmaceutical company does that, then every pharmaceutical company will gain from that, and they can direct their research in other areas into more profitable areas, like new drugs that actually work. And there could be a lot more progress.
It would be interesting to know how many experiments have been replicated because of lack of knowledge of someone else's null result.
Scientific research is an expensive business, but it's a necessary evil. And Amy has actually had some recent experience with the cost of medications. Amy?
Oh, yeah. Yeah. I went to go get my medications and my insurance messed up. So we found out the price, and it was like over $1,000 for all the medications that I tried to renew the other day. So yeah, more than my rent.
Wow.
Yeah,
That's amazing. That's amazing.
You're gonna
Well, do you have
stay
any,
alive or stay dry. Pick one, not both.
Exactly. You know, I either pay my rent and feed my child, or I get my medications if I don't have insurance. It's one of those things.
Yeah, exactly. So do you have any final thoughts on today?
Yeah, it was very fascinating. It's been very interesting, and a lot of the stuff that I do, like with behavioral stuff with my son, that's all evidence-based, the techniques that I use with him, which has been researched. So it's, you know, research is so vital sometimes even to everyday things. I mean, you can find science in just about anything, like even cooking. That's been researched and is evidence-based, and, you know,
Chemistry?
and it comes... Exactly. It's chemistry. So, you know, it's just... There's just so many things where someone else has researched it and has used all the methods necessary to come up with those results that everyone can use in their everyday lives. I mean, it's just incredible. Like last night when my son had a meltdown in the store because we had to wait for so long, I was able to use techniques from applied behavioral analysis and everything to help him through that meltdown, and the evidence that, you know, the research that was used for me to have those techniques worked. So, you know, it's just everywhere.
Handcuffs and duct tape work really well, don't they, Amy?
That they do.
Awesome. And do we have any final messages in the chat that you'd like to bring up?
No, nothing so far. It's just that poor Australia is still burning. So
Yeah, that's a bad situation out there, and I highly encourage our viewers to go check that out and give to the charities to help them out.
Absolutely.
I was going to say, I know your pal done a post or a stream yesterday, or a video, with a link to how you can help with the fires in Australia. So please do go over,
if
check
you'd
out his
like to,
channel.
Stick a
he's
link
in the chat.
In the chat again.
Yeah, please do. And for the rest of you, when your pal puts the link in the chat, I highly recommend you go out, check it out, and give a few bucks. Help these people out. They're in a bad time right now.
They are.
Oh, they are, man. My thoughts go out to you. No, my body prayers are, man. It's
Absolutely.
Absolutely.
And on that note, let's go around the table. And AB, you got anything new coming up that we should know about before we close out?
No, I think we already did the sign-off bits, and then we started going off on a tangent again. Yeah.
All right. How about Apophis? When can we expect the next one?
I don't know. I'm trying to pace them a bit. I'm working on something else, and during the stream here, I got a few things in my inbox which I want to pick up. Some collaborations with other people.
Cool.
So they may come out first. I don't know. The Apophysis, to be honest, they're all uploaded. They're all ready to go. I just need to press, I need to press go live or set the premiere. But I'm trying to pace it because there's a whole lot of stupid, and I don't want people to hurt themselves.
Understood. And how about you, BM? You're back in stateside, and I'm sure you're busy getting all settled in once again. But any plans to bring your channel back up to fresh videos?
Well, I had a couple of videos that I was planning right before I left that I've got the scripts for and I've got the outlines for. Once I get all my equipment, my camera stuff, and the rest of my computer equipment, I'll probably start. I don't know how long that's going to be, but at this point, it's been so much focus on family and the move that honestly, this past week is the most I've even been on YouTube. So it's great to be back with you guys, and I'm going to be on the shills here soon again as a guest. So it's
awesome.
It's great getting back into this community again and seeing all my old friends. Hopefully over the next couple months, I might put out a couple videos here and there, but I can't commit to anything. I'm sorry.
No, perfectly understandable. And we're all really happy to have you back online with us whenever you can. And we wish you luck as you move forward. So
thank you.
You do you, and we'll patiently wait excitedly for your next video. How's that? Awesome. And with that, I'd like to kind of close things out here. We are in transition, moving to the I network from the Logic and Reason site. However, this live stream will be reposted on the Logic and Reason channel for reviewing tomorrow. And over the next couple of weeks, we'll be uploading all of our previous streams one a day for 5 days, and then the following week, same thing again. So watch out for that. Also, because of our transition over to the I network, we haven't really nailed down the topic and guests for our next show. But as soon as we've got that all locked up and ready to go, we'll be posting that out. So watch this space about our next Logic and Reason. And with that, I'd like to say thanks for coming by, and we'll see you all again soon. Good night, everybody.
Good night, everyone.
Good night.
See you.